Hey everyone, welcome back to my channel. In this video, we will create a translator app using MLKit. You already know what a translator app is. It basically translates from one language to another language. In our case, it will translate the English language to the Hindi language. Let me show you the demo. I have kept the UI quite minimal, so have a look. I will write here something in English like maybe, "What are you doing?" and click on the Translate to Hindi button. And look at the translation. It says, "Tum kya kar rahe ho?" Easy? Now, what is an ML kit? But before that, first let's understand what ML is. ML stands for machine learning. It's a technology that allows machines to learn from data. Instead of following fixed instructions, the computer uses patterns and experiences from data to make predictions or decisions. For example, ChatGPT. ChatGPT is an OpenAI based tool. The full form of GPT is Generative Pre-trained Transformer. Focus on the word pre-trained. Means it has been trained on vast amounts of text data. And over time, it has learned to understand language patterns, respond to questions, generate text, and assist in conversations by predicting what comes next based on input. The training process is a part of machine learning. Now, what is an ML kit? MLKit is a mobile SDK provided by Google that allows developers to integrate machine learning features into their apps easily. Let me show you the website. This is how it looks. It provides machine learning for mobile developers. It is available for iOS apps as well as for Android apps. Have a look over here. We have Vision APIs, which includes video and image analysis, APIs such as barcode scanning, face detection, image labeling, document scanners, and much more. Also, we have natural language APIs. So we have one more concept in API, which is NLP, which stands for Natural Language Processing. It involves human language with a touch of technology. For example, robots. They talk exactly how a human talks, right? But obviously they are not humans, they are machines. And that's where NLP comes into the picture. Also, if you'll see ChatGPT, it responds so naturally, as if we are talking to a human. That's the beauty of NLP. See, smart reply, language identification, translation, and all. I will cover a lot of projects from MLKit starting from the Translation app. So click on Get Started. Here choose Android. See, you have a ready-made sample app itself to see how the app works. Then here are the steps like adding Gradle dependency and then creating a translator object both in Kotlin and in Java. So let's create it. Open Android Studio, choose Empty Views Activity, then name the project Translator App and click on Finish. Let's start with the prerequisites. Go to Colors, add blue color with hex code 1E3A8A. Then go to Themes, add the color primary blue, then the color primary variant also blue, and then the Android status bar color also blue. Then do you see this rounded border that we need to create? Hence, create a drawable resource file. Give it a name rounded, edit text. Choose shape and click OK. Then write corner radius 20 dp. And stroke means the border whose width is 2 dp. And color is blue. Next, to make the app look more appealing, we will add a drawable background image. So let me quickly add it. And done. Now we need to add the dependency. Hence go to Gradle app, Then copy the dependency from MLKit website and paste it here. Rewrite it according to our code. This is the MLKit translate dependency. Like for other APIs, we have different dependencies. It stores all the logic that helps us to build apps quickly and easily. Now click on Sync Now. The next is to create a UI. This is what we are going to create. We have text view, edit text, and a button. Now let's create it. I'll quickly write the code and then explain to you only the important points. Okay? and done. Now see, we have used vertical linear layout with our background. Then we have a text view that says English as a label. Then below it an edit text whose ID is input edit text with rounded edit text background. This is where we will write the English text which we are supposed to translate. Then below it a button whose ID is translate button. Then again a text view for the Hindi label. And then another text view whose ID is output text. This is where the Hindi translated text will be displayed. Got it? Now go to main activity. Remove the extra code. This is where we will write the logic. First, declare and initialize all the UI elements, including input edit text, translate button, and output text. And done. Now go to the MLKit website. Step number 1 says to create a translator object, configuring it with the source and target languages. Now, as a developer, you are not supposed to blindly copy and paste the code. Instead, see what part of code is required and what is the purpose of this code. Okay? Also, the documentation does not provide every line of code. Like over here, you have to fill in your logic, right? So copy the code and paste it below the initialization. Here our source language means the language which will be translating is English. You can see here we have so many languages to choose from. English, Hindi, Thai, Arabic, Bengali, Chinese, French, Indonesian, Italian, Japanese, Korean, Marathi, Spanish, Tamil, Urdu, Vietnamese, and so many. I'll choose English, and then our target language means translated language is Hindi. Now here we are predefining the languages, but in Advanced Translator app we can use a language identification MLKit to identify the language on its own and translate it to whatever language we choose from. Here, instead of English-German translator variable, rename it a translator variable, but we will make it a global variable also. Then next, we need to download the model, means the data. Remember at the start I said that every machine requires a set of data or instructions to work. The same way, this code will download the model to the user's device and work accordingly. So to do that, copy the code and paste it here. See, this will require an internet connection to download the model. Then use a translator variable with download model if needed with the above conditions, and then add on success listener means if the model is successfully downloaded, then what are we supposed to do? Translate the text, right? So for that, we will create a separate function for it and then call it here inside. Okay. Now create a function, translate text, whose parameters are input text and output text view. Then copy and paste this code. Here, use the translator variable which will translate the input text, and on the successful translation, it will display the translated text on the output text view. But if the translation fails for some reason, then the output text view will display translation failed. And done. Now here inside the add-on success listener, if the model is successfully downloaded, then set on click listener on translate button. Inside it, first take the English text from the edit text. And then it uses the translate text function which we created before, whose argument values are text to translate means the English text and output text means the Hindi text. But if the model download fails, then the output text will display model download failed. Simple. Then the last thing is to close the translator when not in use. So to do that, create an onDestroy function and inside it write translator.close. And that's it. Our translator app is ready. We do have some more code, but those are for fragments. Okay? Also remove well from here because we have already initialized it here. And we are good to go. Now let's run the app. The app looks great. I'll write an English text. Who are you? Click on Translate to Hindi button and it says, Tum kaun ho? Nice. Let's try I love coding. And it says, Mujhe coding pasand hai. Perfect. If you want to swap the language like translating Hindi to English, then simply set the source language as Hindi and set the target language as English, or maybe any other language of your choice. Also, you can add multiple source languages as well as target languages, but it is recommended to avoid keeping too many languages model on the device at once. Got it? So yeah, that's it for the video. If you are new to this channel, then please consider subscribing to my channel and I'll see you in the next video. Hey everyone, welcome back to my channel. In this video, we will create an image recognition app, or you can also say an image labeling app using MLKit. Now I have already explained to you what machine learning is and what MLKit is in my previous video, the Translator app. You can click on the I button to watch. Also, this is our second project from the series of the MLKit projects. Now, what is image recognition or image labeling? The name itself says it recognizes the image or the object that is present in the image. Let's understand it better with the help of a demo. First, it will ask for camera permission, so allow it. See, this is what the app looks like. We have an image view, a button to capture the image and a text that shows the label of the image. So click on the capture image button. It launches the camera and then click a picture of any object. For example, this plant. Save it and look, it says flower pot. Nice. Let's try a different object. I'll click a picture of this mug. And look, it says a cup. Fair. So you have an idea what exactly we are creating. But let's understand how is it happening. In machine learning, we pre-train the machines with a vast amount of data through which they learn. And instead of following fixed instructions, the machine uses patterns and experiences from data to make predictions or decisions. Likewise, here as well, we are providing the machine, the app, with a model, or you could say vast amount of data, and according to that data, it makes predictions like as it said, flower pot and cup. Got it? I'll make it more simple for you. Go to this website. I'll put the link in the description box. Here we have all the MLKits project, out of which we have already created translation app, and now we are creating an image labeling app. So click on get started. Choose Android. See, this is the documentation code. But I know it looks quite complicated. Hence, refer to the code that I'll be writing. Okay? Now one more thing. Let me show you the data. Click on the label map. And see, this is the default model with 400 plus labels. All of these labels have image data. through which they compare our image with their image data. Like I click an image of a flower pot, so behind the scenes the machine starts scanning the entire list of data and tries to find something very similar to that image, which in our case is a flower pot. If it is available, then it displays a label as a flower pot. Otherwise, it says label not found. Got it? Now let's create it. Open Android Studio, create a new project, name it Image Label App, and click on Finish. Let's start with the prerequisites. Go to Gradle app. Here add image labeling dependency. Copy and paste the code. Rewrite it. And then click on Sync Now. Next, go to Colors. Add a blue color with hex code 0096FF. Then go to Theme. Add Color Primary. Color Primary Variant. And status bar color as blue. Then go to Android Manifest. Here we need few permissions from the user, like internet permission, camera permission, and storage permission. And then also add users feature tag. Lastly, we will add an image icon in the drawable folder. And our prerequisites are done. Now it's time for designing. So go to activity-main.xml. Here we will create a simple UI that consists of an image view, a button, and a text view. So write along with me. add font family pop-ins, and done. Now look, we have a vertical linear layout, and inside it an image view whose ID is object image with a height of 400 dp and our image icon. Then below it a button whose ID is capture image button with the text capture image. This button will launch a camera and capture the image as the name says. Then lastly a text view whose ID is label text. This is where we will display our image label, and that's it. Now go to main activity, remove the default code, declare all the UI elements like object image whose data type is image view. Then label text, also initialize them. And done. Now we have to handle two things. One is the label part and two is the camera part. So first let's start with the camera part. Step number 1 is to check for the camera permission. Now you will be wondering, we have already asked for permission in Android manifest. So why check it again? Because after API 23, it is mandatory to request runtime permissions for precautions. Hence create a function check camera permission, and this way then check self permission camera, is not equal to permission granted. Means if the camera permission is not given, then request for camera permission. And that's it. Don't forget to call check camera permission function here inside the onCreate. Then next we need to declare a variable camera launcher that starts the camera with the help of activity result launcher. Now initialize it. First let me write the code and then I'll explain. This code starts the camera and also set the captured image on the image view. So see, this registers a launcher that will handle the result of an activity. In this case, the camera activity for capturing images. Then it checks if the image capture operation was successful, result OK. Then it retrieves the captured image from the intent data as a bitmap object using the getParsable method. Means whatever the image is captured, it stores in image bitmap. Also add the annotation. It means getParsable works for API greater than 33. Means whatever comes after tiramisu. Then it checks if the image bitmap is not null. Means image is present. Then it sets the image on our image view. That is object image. Else it displays a text on the label as unable to capture image. Till now, we have camera permission as well as an image on our image view. But all of this are possible only when I will click on capture image button, right? So declare an initialize capture image button. Then set onClick listener on capture image button. And inside it, create an intent of action image capture. Means go to the camera app. Then if click picture is not null, means the camera is present on the device, then use camera launcher which we created before and launch it with click picture. And our camera part is done. Now let's write the code for label part. So first create an image labeler variable. And initialize it as well. Basically, this gives a label to our image. Also, if you remember, we saw a list of labels. Those are default options. And that is what we have initialized here. Then outside the onCreate, create a function label image with bitmap parameter. Then inside it, initialize the input image means convert the captured bitmap into an input image object, which is required for processing with MLKit. The second parameter 0 specifies the image rotation. 0 means no rotation. Then with the help of image labeler, process the input image. Remember the word I said scanning means going through the data list, and if it finds a similar kind of image in their list, then it will display its label. Else a technical error. But we will create a separate function to display the label. Hence create a function display label with a parameter labels, whose data type is a list of image table. If you will click on image label class, you can see what kind of parameters you can display, such as text means the label itself, confidence means accuracy, Index means the position of the label, and mid is machine readable identifier like an ID. Then inside it, write if labels is not empty, then display the most confident label. So it's a list, means the machine will predict a lot of labels, like for example the flower pot. It can also be a plant or flower or leaves, right? But I want the most confident or accurate label, which is usually the first one, means at the 0th position. That label will be displayed at the label text view. Else, if anything goes wrong, then it will display no labels found. Now, we will call this display label function here inside the add-on success listener with the argument label. Lastly, the label will be displayed after the image is captured. So come here inside the onCreate. Here in the camera launcher, as soon as the image is set on the image view, the next immediate thing will be to display the label. So right below it, call label image with image bitmap as an argument, and that's it. Our image labeling app is ready. Now let's run the app. Give the camera permission, then click on the capture image button, and let's take a photo of our glasses. And look, it says glasses. Quite accurate. Then let's try a book. And it says paper. Close enough. I won't say it is perfect or will show you the accurate labels. Not necessary. But it does give you pretty decent predictions. See, it has only 400 something label, so you can't expect it to work like a Google Lens app, right? It's a base model and it pretty much does what it says. Also, to make it a little more advanced, you can add additional features like to display a list of labels instead of just one label, and maybe with a confidence value in percentage. Then you can also integrate the image recognition code as a feature in any other app of yours. Cool, right? So yeah, that's it for the video. If you're new to this channel, then please consider subscribing to my channel, and I'll see you in the next video. Hey everyone, welcome back to my channel. In this video, we will create a text recognition app called an OCR app, which stands for Optical Character Recognition using MLKit. In simple language, we will extract text from an image. Got it? Also, this is video number 3 from the series of MLKit projects. You can check out the other 2 videos by clicking on the I button. Now, let me show you the demo. This is what the app looks like. Very minimal. I will click a picture of this book. Then save it. And look, all the text that is present in the image is successfully extracted. And the best part is that you can copy the text and paste it wherever you want. Isn't that cool? Now, I know some of you wondering what's the use of it. OCR apps are generally used in data entries, legal documents, accounting, logistics, or communication. Basically everywhere. For example, if someone gives you a handwritten document, OCR can scan handwriting as well and save it in a digitalized format. Now, how all of this is happening? Let me show you. Go to the MLKit website. Here we have different APIs, out of which we have already created the translation app and image labeling app. And now we are creating a text recognition app. So click on Get Started. Here you can see the best part is that it not only recognizes the English language but also Chinese, Devanagari, Japanese, Korean, and Latin scripts. It supports symbols, elements, lines, and paragraphs. Then it also identifies the language. See, these are all the supported languages in detail. Like we have Afrikaans, Filipino, Hindi, Bahasa Indonesia, Italiano, Marathi, and many more. Now, what's the logic behind it? See, it's very simple. With the help of machine learning, we provide a model or data to our machine. And what is that data? A set of characters. We have multiple languages, and each language has its characters or alphabets or letters, right? All of these are stored as data in our machine. So when you capture an image, the machine analyzes the pixel of that image and compares it with its database, which consists of characters. If it finds a similar looking character in the database, then it simply displays the character. Easy? Now let's create it. Open Android Studio, choose Empty Views activity, name it Text OCR App, and click on Finish. Now come back to the MLKit website, choose Android. Here we have basic code to create a app. You can refer to this code or you can create a customized app on your own. My code will be slightly different from this code because I am adding additional features too, but there will be few things that will remain the same, like Gradle dependency. So copy the dependency and paste it here in the Gradle app. Rewrite it. Also, I am keeping the app very simple, so I am not adding other languages dependencies, but you can add them if you want. Now click on Sync Now, then go to Colors. Add green color with hex code 00BF63. Then go to Themes, add color primary variant, and Android status bar as green. Next, we need an image icon. So add a vector asset to the drawable folder. Then, we also need a border around the text view to make it look more appealing. So create a drawable resource file border. Here, inside it, create a rectangle shape with a stroke width of 2 dp and color green. Then add a corner radius of 20 dp. And done. Now focus. When you capture an image from the camera, it is saved in the photo gallery, right? And we need that captured image from the photo gallery. So how do we get that? There is a concept called secure file sharing between two apps. What are those two apps? Our app, text recognition, and the photo gallery app. Photo gallery app shares the captured image with our app. That's where file sharing is happening. But this file sharing is not secure. Means the path of the image is exposed to the other app, which is a potential risk. So to avoid that, we use file provider class. What is a file provider? File provider allows your app to securely share files with other apps without exposing the underlying file paths to external apps. So, how do we achieve it? First, we need to inform the location of the image to the file provider. Like if the image is present in internal storage or is it present in external storage. So to do that, in XML folder, create a new XML resource file. Give it the name provider paths and choose paths. Here inside it, write an external path because our image will be stored in external storage. Then give it the name external_files. This is the path name and the path is a dot, which means the entire external storage directory is accessible by the app which can be shared. Now, this is the file that we will attach with file provider. So go to Android manifest. Here, inside the application, write the provider tag. And inside that tag, authorities consist of app ID, then write the name, file provider, then exported false. Means other apps are not allowed to access other than one you gave the permission. Then grant URI permissions, true. Means it allows read-write permission. And then finally the metadata, whose name is file provider paths. With resource, the file which we created, provider paths. And that's it. One more thing, don't forget to add camera permission. Also add for hardware and done. Now let's design the UI. So go to activity main. Here we will create an image view to display the captured image. 2 buttons, one is to launch a camera and 2 is for copying the text. Then 2 text views, one is for OCR text label and 2 is where the OCR text will be displayed. So let's create it. First, create a linear layout whose orientation is vertical. And padding is 16 dp. Then inside it, an image view whose width is match parent and height is 200 dp. Its ID is camera image. With src image icon. And other required attributes. Then below it, create a button whose width is match parent and height is wrap content. Its ID is capture image button. With other required parameters. Next, create a text view whose width and height are wrap content. It is a label text, so the text is OCR text. And other required parameters. Then below it, another text view whose width is match parent and height is 280 dp. Its ID is result text. This is where the OCR text result will be displayed. Add other required attributes as well. Here, notice I have used vertical scroll bars because the OCR text can be a few lines or multiple lines. Hence, we will add a scroll bar so that the user can scroll through the entire text. Lastly, create a button whose width is match parent and height is wrap content. This button will be used to copy the text. Then its ID is copy text button and other required parameters. Also, I have kept the button initially invisible because at the start there will be no text to be copied. So why show the button, right? And that's it. Now let's write the logic. So go to main activity. Here, declare and initialize all the UI elements like camera image view, capture image button, result text view, and copy text button. And done. In this entire app, recognizing the text is the easiest code to write. But launching a camera and then capturing the image and all of that requires a lot of code to write. But that's okay, we will go easy. Now, the image that we capture from the camera, that image is temporary. What I mean by temporary is that it will not be present in your photo gallery permanently. User clicks a picture from our app, it recognizes the OCR text and displays the result. That's it. There is no storing the image in the photo gallery permanently. Got it? Now to do that, first we need a photo path to represent particular photo. Hence create a current photo path variable whose data type is string and whose initial value is null. Simple? Then outside the onCreate, create a function, create image file, which will return us a file. Inside it, we will create a timestamp variable. In this way, means it will store the time as well as the date. Then create a storage directory variable whose data type is file. It basically stores all the external files that we give access to. Remember using file provider? Then in return, it will give us a temporary file that has the current timestamp. JPG file extension, and it is present in external storage. That file, absolute path, is stored in our current photo path. And that's how we got our temporary image file. But we will get all of this when an image is captured, right? So let's create a function for it, capture image. We will be doing reverse engineering here in main activity. Keep watching. Now, here inside it, create a photo file variable whose data type is file. Then add a try-catch block to avoid errors. So try creating the image file, the function which we created above, And while creating it, if any error gets captured, then throw a toast, an error occurred while creating the file. Now, all of this will happen when we launch a camera, right? But the camera will launch when the user grants the permission. So let's write the code for it. I know you have already asked for camera permission in Android manifest, but we do have to ask the permission here in logic as well. So declare a variable request permission launcher whose data type is activity result launcher string. Now initialize it here inside the onCreate. So write request permission launcher is equal to register for activity result, and inside it the activity result contracts dot request permission. Then inside it is granted. If is granted is true, then capture the image, the function which we created below. Else throw a toast, camera permission denied. Simple. Now, once we have the permission, then next what? Launch the camera. So to do that, declare a take picture launcher variable whose data type is activity result launcher. URI means the path. Then initialize it here. Take picture launcher is equal to register for activity result, and inside it the activity result contracts dot take picture. Then inside it, if it is a success, then get the current photo path and decode the file path with the help of bitmap factory. And once we have the image, then set the image on our image view, that is camera image, and done. Also here inside the capture image function, store the URI means the path. So get the URI for the file through file provider, and store it in the photo URI variable. And then launch the take picture launcher which we created before by passing the photo URI as the argument. Now we are writing all of this for what? Recognizing the text, right? So let's write the code for it. Outside the onCreate, create a function recognize text with bitmap as the parameter. Then inside it, create an image variable that will store our captured image. And then create a recognizer variable that will store the default options, means the model, the data, or the characters of the languages that we saw previously. Now, this is important. It is present here in the documentation as well. So write a recognizer dot process the image. Our image with add-on success listener and add-on failure listener. So if the text is successfully recognized or extracted, then display it on our text view result text. Then remember, we added a vertical scroll bar on our text view, so initialize it here as well. Scrolling movement method. Also, we have kept the copy text button invisible at the start, but as soon as the OCR text is displayed, then copy text button will be visible. And let's add functionality into our copy text button. So set on-click listener on it, and inside it, basically we'll store our text in our clipboard. So initialize the clipboard. And clip as well. Clip is our OCR text. Then set primary clip means copy our clip, our OCR text to the clipboard. And throw a toast, text copied. In add-on failure listener, throw a toast, fail to recognize text with a technical error. And then call the recognize text function here inside the take picture launcher after the image is set on the image view with our bitmap parameter. Lastly, all of this camera permissions, launching a camera, capturing an image, displaying an image, then recognizing the text, everything will happen when capture image button is clicked, right? This is the last stage of reverse engineering, so set on click listener on our capture image button, and inside it request for camera permission, the function which we created before, launch it, choose Android manifest permission, camera, and done. So basically everything starts from here by clicking on the capture image button and ends over here by recognizing the text. And that's it. Now let's run the app. I will click on capture image button and grant the camera permission. Click a picture of this document, save it, and look, it extracts the text from the image. Great! Now you can copy the text and paste it anywhere. Isn't that cool? Also, you might face issue when the device screen rotates, because that leads to image rotation, which can cause problem while recognizing the text. But don't worry, the code for handling the image rotation is already present in the MLKit documentation. So you can refer that if required. Okay? So yeah, that's it for the video. If you are new to this channel, then please consider subscribing to my channel, and I'll see you in the next video. Hey everyone, welcome back to my channel. In this video, we will create a QR code scanner app using MLKit. You know what a QR code scanner app is, right? But what you need to know is how QR code works. First, let me show you the demo. As soon as you open the app, the camera opens. Scan the QR code or a barcode and it automatically displays the QR code's content here. If the content is text, then it simply displays it. But if the content is a URL link, then you can click on it and the link will be opened in a web view. Isn't that cool? Now, how a QR code works. Do you see these little black and white squares? They are binary. I am sure you know that a binary is 0 and 1. So the black square is 1 and the white square is 0. So a QR code stores data as a pattern of black and white squares. Each square in the QR code represents a bit of information like letters, numbers or symbols. When a scanner reads the QR code, it translates this pattern into a readable information, such as text, a website link, or a contact. The scanner uses the alignment and timing patterns within the QR code to ensure it reads the data accurately. See, these 3 boxes are fixed. They help the scanner understand the orientation of the QR code. The remaining area contains the data. Also, in large QR codes, small additional squares appear in specific area to help with alignment. Got it? Now, let's create it. Open Android Studio, create a new project, name it the QR Code Scanner app, and click on Finish. As I said at the start, we will be using MLKit. So go to MLKit website. We are creating this barcode scanner project. So click on Get Started. Now, how does ML play a role in QR code scanner? ML algorithms help identify barcode patterns from a live camera feed or image. Once the barcode pattern is recognized, ML models are used to interpret as data. This is done by mapping the black and white squares to specify the binary sequence that are 1 and 0. And according to that, our data is displayed. Now let's create it. So copy the dependency and paste it here in the Gradle. We are also using the camera for scanning the barcode, hence adding camera X dependencies. Camera X makes the process of adding a camera to your project very easy. Then click on Sync Now. And done. Next, let's add permission for the camera. So go to Android Manifest, add camera permission, also add its hardware permission. Then our app will consist of 2 screens. One is where the camera will be for scanning and 2 will be our web view, where the websites will be displayed. So let's create the second activity. I'll name it Web View Activity. And done. Now let's design the UI. So first go to Activity Main. Here the UI is very simple. We will have a preview view, which is our camera view, and a text view where the QR code content will be displayed. Easy. But what exactly preview view is? See, in the preview view, camera will automatically detect the QR code without capturing an image or storing an image. And also it makes the entire process very seamless. Like if you have seen my previous video of the MLKit project series, there we have created an image labeling app and a text recognition app, where ML part was easy, but the camera part was so hectic, like permissions, launching the camera, clicking a picture, then storing the image and then retrieving the image and displaying it. Too much of work, right? Now, you will see how camera X reduces the amount of work that goes behind it. Then below it, a text view whose ID is result text view, with width as 0 dp and height as 100 dp and other attributes. Next, let's design an activity web view. Here also the UI is very simple. All you have to do is add a web view. And then, now let's write the logic in main activity. So declare and initialize the UI elements which we created in activity main XML. Those are preview view and text view. Now, step number 1 is to request camera permission in logic. So write, well, request permission launcher is equal to register for activity result contract dot request permission. Then inside it, create a variable is granted whose data type is boolean. So if is granted is true, means camera permission is given, then we are supposed to start our camera. So I will create a separate function for it as start camera. Else, in result text view display camera permission is required. Then request permission launcher dot launch means to request the camera permission through manifest. Like, do you see those dialog boxes that ask for permissions? That's what this is. Now let's write the code for start camera function. This function sets up the camera for a QR code scanner app using camera X. So write along with me. Well, camera provider future. It retrieves an instance of process camera provider which controls the life cycle and connections of the camera. Then we need to set the screen resolution for which we use size and resolution selector. So write, well, screen size. Here the target resolution for the camera preview is set to 1280 into 720 pixels, ensuring the camera matches this resolution if possible. Here the fallback rule is set to none, which means no alternative resolution is used if the size is not available. Next, we need to set preview. So for that, add listener on camera provider future, and inside it we will create preview object. The preview object is created and configured with the resolution selector. The setSurfaceProvider method then attaches this preview to the preview view UI component, allowing live camera feedback on the screen, means automatic detection of the QR code. Then, once the QR code is detected, then next we need to analyze it. So for that, we will use image analysis. This setups an image analysis instance for frame-by-frame analysis for a QR code scanning. The strategy: keep only latest. backbrush strategy discards all frames to avoid lag. Then we need to set the analyzer. So for that we need to create a camera executor variable. So executor service is provided by MLKit and also initialize it. Then here set analyzer method assigns an analyzer to process frames. For that we will create a separate function where the ML will process the image, means display the QR code result. So for now I will leave it blank. Then we need to adjust a few settings of camera, like default camera will be the back camera. Then next bind it to the app's lifecycle, this. It links the preview and image analyzer components. So the camera provides live feedback to the preview view and processes frame for analyzer simultaneously. Now let's write the code for image processing. So create a function process image proxy with image proxy parameter. Then inside it, proxy image, means the QR code that it detected will be stored in the media image variable. Then if the media image is not null, it's converted into an input image object required by MLKit's barcode scanner. The rotation degree parameter ensures that the image is correctly rotated for accurate scanning. Next is very important. Here we need the barcode scanner to process the image. So create a variable barcode scanner. Also initialize it. And then over here, barcode scanner dot process the image. Stands the input image to MLKit's barcode scanner, where it detects and decodes any barcodes or QR codes. If the barcode is successfully detected, the add-on success listener retrieves it in the barcodes list. Here we will handle the barcode, for which we will create a separate function later. This method will open our link in the web view. Then if there is an error during scanning, then add-on failure listener sets a failure message in result text view as fail to scan QR code. Regardless of success or failure, add-on complete listener ensures the image proxy is closed, freeing up memory and allowing the next frame to be processed. Then we can call this process image proxy here inside the image analysis with an image proxy argument. Now, capturing, analyzing, processing and displaying the content of the QR code, everything is done. Next, what we need to do is what to do with the content. Like if it is a URL or a link, then we are supposed to open it in a web view. So let's write the code for it. Create a function handle barcode with barcode as a parameter. Then write along with me. Now, this line attempts to retrieve the URL if the barcode contains 1. If no URL is available, it uses the barcode's display value instead. This ensures that any content in the barcode is captured even if it is not a URL. Then, if the URL is not null, it sets the content as the text of the result text view. Then set onClick listener makes the text clickable. Clicking it will open an activity which is a web view activity. Also, we will pass our URL to the web view activity, and in the web view activity, we will receive it. Otherwise, if no content is detected in the QR code, then it will display no QR code detected. Now, you can call this matter here inside the process image proxy with barcode as a parameter. Then finally create an onDestroy function that will close the camera executor if it is in no use. And that's it. Lastly, let's write the logic for WebView activity. Here, declare and initialize the web view which we created in WebView XML. Then remember we pass a URL from main activity. That's what we need to receive here. So write well URL intent get string extra, and the key should be the same. So it's URL in small. Then initialize WebView client. And JavaScript enabled as true. Enabling JavaScript allows a more interactive experience on the website. Next, if the URL is not null, means the QR code contains a URL, then load the URL in a web view. And that's it. Our QR code scanner app is ready. Let's run the app. See, first it asks for camera permission, so allow it. Then automatically the camera is open. And now look carefully. The camera will automatically detect the QR code and display the result. Like, this QR code consists of text, so even if you click on it, nothing will happen. Let's try a different QR code. So this one has a link. And when I click on it, look, the website is open using WebView. Isn't that amazing? So yeah, that's it for the video. If you are new to this channel, then please consider subscribing to my channel, and I'll see you in the next video.